Right, sent them out to play. Let's get this finished in peace and quiet. Number 11, change subject of the formula to A. So what we're looking for, what this means is we want to find, basically our answer is A equals. That's what we're looking for, okay? So we've got this equation, we're going to rearrange it a bit, okay? Remember, change the sign, change side, all the rest. Move things across the equal sign so that we finally have A on its own, A equals, and everything else on the other side. Right, what I would tend to do in a question like this is to get A on its own, I'm going to, at the moment A is on the right hand side, I'm just going to switch the whole thing round, okay? I prefer to do that. So I'm going to have ut plus a half at squared is equal to s, okay? Nothing, no signs are changing, right? When you shift the whole equation round, nothing changes, okay? So I want to get a on its own. This wee bit doesn't have any a at all. I can move that across straight away onto the right hand side, and if I do that, it leaves me with a half at squared equals s, and what am I doing with this side? I'm going to take it away, take away ut. Okay, now be careful with this part over here. First thing I'm going to think of that as a division by 2. The 2's on the bottom, it's a divide by 2. So if I get rid of that divide by 2, how do I get rid of a divide by 2? I multiply the other side by 2. 2 times s minus ut. Okay, nearly there. We want to get a on its own, right? What's stuck to the a? The t squared. What's the t squared doing to the a? It's multiplying by the a. It's stuck to it. It's getting multiplied by a. How do we get rid of a thing that's getting multiplied? We divide. I hope there weren't any people sitting there thinking we take the square root. No, we don't take the square root. If it said a squared equals, then yes, to get rid of the square root, we would we would do the square root. But the a isn't squared. It's the t that's squared. So we're just simply moving the t squared onto the right by doing a division. Number 12, this is a trig equation. So let's see, just think of it as a normal equation at the start. If this was a normal equation, what you would be doing, if that cos x was actually just x, what you'd be doing is you'd move the minus 2 across. That's the first thing you would do. And that would leave you with 11 cos x is equal to 3. Move the minus 2 across and it becomes a plus 2. So on this, we have 5. Okay, we want to get cos on its own. Next thing we're going to get rid of is the 11. Cos x equals, what do we do with 11? Well, what is 11 doing with the cos? It's multiplying by the cos, so we divide by 11. Okay, get your calculator, make sure you're in degree mode. 5 divided by 11, that comes out as a wee 0.45 roughly, okay? Don't round anything at the moment. So that's what cos x equals. We're trying to find out what x equals. X in trigonometry, we're talking about an angle, okay? How do you find x? Well, x is, what do? You do the inverse cos, just the same as we've done with that, the wee one earlier. Okay, you should be able to leave that 0.454 on your screen in your calculator, and you should really just be able to press Shift cos without having to type the number in again. If we do that, I've got 62.96 roughly. Okay, I'll leave it like that. Now, be careful, this is not finished. Remember, again, depends which teacher taught you this. You may think of something like a cast diagram. Okay, there might be people thinking of some kind of diagram like this. There might be some people thinking of ASTC, all sinners take care. If you're in my class, this is how we done it. Okay, cos, and that's a positive number. So cos equals 0.454. Cos is positive. Which two quadrants? Because there's always two quadrants where sine, cos and tan are positive and negative. Cos is positive. They're all positive in the first. And cos is also positive in the fourth. The calculator answer always gives us our first quadrant answer. So that is one of the answers we're looking for. But we're also looking for the fourth quadrant as well. Okay, and to get your fourth quadrant, what you actually do is 360 minus your first quadrant answer. gives you about 297 point, that'll do. Okay, we're not, when we're saying we're not worried about rounding, see if it was 297.8, you couldn't leave it as 297, okay? So make sure you round sensibly, although they're not specifying to how many decimal places, that'll do, okay? Or 63 and 297. Right, last one. Here is the entrance to a tunnel. It's in this shape. Looks like an arc sector or maybe a trig question. It looks a wee bit like a Pythagoras question. It looks like a mixture of all of them. Let's have a wee look. We've got the chord, we've got an angle of 50, the radius is 7. All the information there is marked on the diagram. Calculate the area of this cross section. We're looking to find the area of this whole shape. The whole shape. The bit that looks like the sector of a circle, but it also has a triangle as well. This is a 5 mark, I think it's the last question in the paper. There's 2 steps to this. We need to find the area of the triangle. Angle is 50, 2 sides are 7. We need to find the area of that, and we need to find the area of that bit as well, which is an arc, area of the arc. Okay, or area of the sector even, rather than the arc. Okay. So there's 2 parts to this. We need to find the area of the triangle and the area of that sector, and then we'll add them both together. Okay? Right, I'm just going to take it over to this side. Right, we're going to find the area of the triangle first. That was 50 degrees, it was 50, and both sides were 7. Right, you have a formula list. There it's there, there's your formula list, and one of your formulas show you how to work out the area of a triangle. There it's there, okay? The area of a triangle, the area equals a half AB sine C. A and B are your 2 sides, and C is the angle in the middle. So this is a half times 7 times 7 times sine of angle C. And we're talking about sine of angle C, it's the angle 50. Okay? Again, make sure your calculator's on your degree mode. 1 divided by 2, or just type in 0.5, times 7 times sine 50. 18.768, we'll see. And you'll notice I'm not rounding anything, I'm leaving it like that just now. I'm not putting units in, it's not a final answer, we'll leave it as that just now. Okay, I'm going to get rid of this wee formula list, please. Delete. And now I'm going to work out the area of this bit. Okay, now what you do know is the angle in here is 50. However, the area that we're trying to find is the area of this bit, not the bit with the angle of 50, the surrounding bit. Now, the area of a sector, right, arcs and sectors, it's the angle over 360 times by, what's the area of a circle? Pi r squared. Right, now we're not using 50 degrees here, because if we use 50 degrees, we're working out the area of the bit that has been chopped out. Okay, so it's actually the angle that we want to use is this angle here. 360, take 50, that angle is 310. So it's 310 over 360 times by pi r squared. The radius, 7, isn't it? Yep. Okay. 310 divided by 360 times by pi times by 7 squared gives 132.55. And now you'll notice again I'm leaving quite a few numbers at the end. I'm not going to stop there, I'm going to back and read the question. I'm looking in particular for any particular rounding, and I'm also looking for the units as well. Calculate the area of the cross section. So it's not worrying about rounding, but it does say these measurements are in metres. Okay, so the total area, we're going to add the 2 together. I'm going to add on that 18.768 onto the last number, and I get 151. Round sensibly. I know it doesn't say any, specify any rounding. I'm going to go for 0.3. Okay, after the 3 is a 2. And this is the measurements are in metres, area, metres squared. Okay, and I'm pretty sure that's the last question. Yep. Okay. Best of luck. Take notes as you go and have a wee go at the questions. Okay. And remember, we're looking for you then to upload pictures of what you have done. Mrs. Bonner's put a wee info video to show you how to do that. I know you might not get it all done by the end of Friday afternoon. I'm happy if you can upload that for me for Monday at the latest. Okay, good luck and have a good weekend. Bye bye.